Right, so in this video we'll look at Newton's first law and Newton's second law, starting with his first law. So we've briefly touched on his first law when we looked at resultant forces. So his first law says that if there is no resultant force acting on an object, the object will continue moving at whatever velocity it was moving at. Okay? Okay, so if no resultant force acts on an object, its velocity won't change. So so we're worried about the resultant force and its velocity. Now remember, velocity takes into account speed, and because it's a vector quantity, it takes into account direction as well. Okay, so in other words, if no resultant force acts on an object, okay, that means if the forces are balanced acting on an object, then it won't change its speed and it won't change its direction. Let's take this block for example. This block here has no resultant force acting on it. You can see that there's no resultant force acting on it. Now that means its velocity won't change. Now currently it is stationary, okay, so it will remain stationary, it won't move. If I applied a resultant force to the block, then it will start to accelerate. Now if the block was already moving, okay, if the block was already moving, now currently there's still no resultant force acting on it, okay, but it is moving. It's just not accelerating, okay, so its velocity is not changing. So it's going to carry on moving at the speed it's moving at in the direction it's moving at. Yeah, and that's what Newton said in his first law. No resultant force, it's not going to speed up and it's not going to change direction. Now if I applied two forces to the block, let's apply two forces. Let's say I've got 5 newtons to the right. Let's also apply a 5 Newton force to the left as well. Right, so you can see then that the forces are balanced. There is no resultant force acting on this block. Now, the block is still going to move at a constant speed. If the block was moving at, say, this speed, yeah, it's going to carry on moving at that speed, and it's not going to change its direction either. Okay? If the block was stationary, like now, then it will remain stationary. Okay, now you can actually change an object's direction, yeah? So let's say I've got this aeroplane here. Now, if this aeroplane was moving, okay, currently there is no resultant force acting on it, so it's going to carry on moving in whatever direction and speed it's moving at. If I applied a force to the bottom of the aeroplane, and I applied a force upwards, okay, then the aeroplane is going to change direction, okay? So the aeroplane will no longer be moving in a straight line, it will start to move upwards, so it's changing direction, okay? Now if I applied a force downwards instead, I applied a force down, let's get rid of this upward force, replace it with a downward force, then you can probably tell me which direction the plane will move in. Yeah, clearly it will start moving downwards like that, it will change direction downwards, okay? Right, if we have a look at Newton's second law, okay, what is Newton's second law? His second law is very similar to his first law, okay, except it takes the form of an equation. It takes the form of F equals ma, okay, force is equal to mass times by acceleration, okay. Right, so this is resultant force here, so the resultant force on an object in newtons is equal to the mass of the object in kilograms multiplied by the acceleration it experiences. Okay, and this is one of the fundamental equations that you do need to know. So acceleration is in meters per second squared. So F equals ma. Why is this similar to his first law? Well, if you make F 0, if you make F equal to 0, m is going to have some value, okay, unless it's not got any mass, but it's going to have mass, so it's going to have some value. A therefore has to equal 0 in order to satisfy the equation, so acceleration will be 0. It's not going to change velocity. Right, so the block above, the orange block, what's the resultant force on the orange block? Well, we know how to calculate resultant force. Resultant force is just the forward force minus the backward force. So 500 subtracted from 200 subtracted from 500 is going to give us a resultant force to the right of 300 newtons. Okay, if we take that 300 newtons and we divide it by the mass of the block, which is 10, it's going to accelerate to the right. Okay, so let me just sort that 0 out. 300 divided by 10 is 30 meters per second squared of acceleration, and it's going to act to the right because it's going to accelerate to the right at 30 meters per second squared. Right, if you think you can have a go at this question here, please do. I will put the answer in the description below, and I'll see you in the next video.